Welcome friends in B.Sc first year. Today we are going to start the physics paper number 5 in semester second. The name of paper is Electricity and Magnetism. In this paper we have 4 chapters. Chapter number 1 from the section of mathematical physics, that is electricity and magnetism. In the course electricity and magnetism, that is vector algebra, that is from the mathematical physics. One more book we have to use for that, that is mathematical physics book, gas and electrostatics is the second chapter from the electricity. That is, we have to consist of a Kumar and Gupta books we have to use here. Also one more topic for the magnetostatics in the magnetism, and the last one is again electricity, that is transient current. These are the 4 topics we are going to consider this course. So this course is very important for the B.Sc semester second, and in this course today we are going to start the topic number 1, that is a vector algebra. This is the first topic we are going to study here, vector algebra. In this vector algebra we have a first article, that is dot and cross product. In the dot and cross product, basically we have studied this article in the previous year syllabus. We have in 11th and 12th standard we have already studied what is the dot product and cross product. These are also called as scalar product and vector product. Basically we have in physics 2 types of physical quantities. One is called as scalar quantity and another is called as what? A vector quantity. In the scalar, we have considered only magnitude, the physical quantity which have only magnitude. Such a quantities are called as a scalar quantity. They are completely prescribed by a number and unit. They are called as scalar quantities. Then vector means the physical quantity which having magnitude as well as direction. Such a quantities are called as vector quantities. Basically these are studied in the 11th standard. Now in our syllabus, first article is what? Dot and cross product, a revision. First of all, what do you mean by a dot product and what do you mean by a cross product? We have to study one by one. Basically, dot product means what? We have discussed first here. Dot product is also called as a scalar product. It is also called as what? A dot product. Now what is dot product? We have, take the revision here, that is definition for dot product. That is, we have to consider mathematically here, A bar is the first vector and B bar is the second vector. We have to take the dot product between A and B. Means we have A bar dot B bar is equals to AB cos theta. Scalar product is also called as dot product. A bar dot B bar is equals to what? AB cos theta. That is, scalar product of 2 vector can be defined as product of, this is what? A product of magnitude of 2 vector. A bar चा magnitude आहे A, B bar चा magnitude आहे B. Product of magnitude of 2 vector and cosine of the angle between them. This is called as what? A scalar product. This is, we have to say that a first vector is say A bar and second vector is what we have to say that B bar, and angle between these two vectors is considered as say theta. So we have to say that scalar product of two vector can be defined as product of magnitude of two vector and cosine of the small angle between them. This is the definition for a dot product or a scalar product. Here we have some properties of the dot product. First property we have to consider characteristics or properties. Scalar product obeys commutative law of vector multiplication. A bar dot B bar is equals to what? AB cos theta. A bar dot B bar is equals to, we have to say that, AB cos theta. And secondly, B bar dot A bar is also equals to what? BA cos theta. And finally, A bar dot B bar is equals to B bar dot A bar. This obeys a commutative law. Commutative law of vector multiplication. Scalar product obeys commutative law of vector multiplication. Secondly, scalar product can also obey a distributive law of multiplication. Second property we have distributive law of vector multiplication. What we have distributive law? That is A bar dot B bar plus C bar is equals to what? A bar dot B bar plus A bar dot C bar. This is called as what? Distributive law of scalar multiplication. Scalar product obeys commutative law. It also obeys what? Distributive law. We know the distribution at what? A bar dot B bar plus A bar dot C bar. This is called as a distributive law of multiplication. Now we have to consider another characteristic or property for the scalar product. What we have to say that if the angle between two vector is say 90 degree, what will happen that if first, what we have to say that theta is equals to 0 degree. What will happen? Therefore, A bar dot B bar is equals to AB into cos of 0. And what is cos 0? That is 1. Means we have to say that is equals to AB. If the angle between two vector is 0, the scalar product of two vector is equals to product of magnitude of two vector only. Second, if angle between two vector is say 90 degree, here we have to say that two vectors are parallel. दोन vectors are parallel असतील. Parallel line मध्ये angle किती असतो? Let us see here, this is the first vector and this is second vector, that is say A bar, and this is what we have to say that B bar. So theta is equals to 0. Two parallel lines, angle should be 0. Now what will happen that two vectors are perpendicular, means one vector is like that and another vector is this one. What we have to say that this is A bar and this one is what? B bar. Angle between two vectors is say 90 degree, perpendicular to each other. What will happen that therefore A bar dot B bar is equals to AB into cos of 90. And what is cos 90? That is 0. What we have to get that equals to 0. Means if two vectors are perpendicular to each other and its scalar product should be 0. If two vectors are parallel to each other, its scalar product is product of its magnitude. Next, if two vectors are anti-parallel to each other, theta is equals to 180 degree, anti-parallel. Means we have one vector in this side and another vector in this side. There, so that angle between them is what? 180 degree. And cos 180 is what? Minus 1. So A bar dot B bar is equals to AB into cos of 180. Cos pi is minus 1. That is equals to what? Negative product. That is magnitude of magnitude of product of two vector. And these are the some, what we have to say, that characteristics of a scalar product. Now, what is the scalar product unit vector property? Unit vectors. That is, we know that unit vectors are I cap, j cap, and k cap. For Cartesian coordinate system, we have to consider, this is what we have to say, that this is x-axis, this one is a y-axis, and this is what we have to say, that z-axis. This vector having unit vector is a I, this is what we have to say, that j, and this is third one vector is what we have to say, that k, and these are called as what? I, j, k are the unit vectors. And what is unit vector property? That is, we have to say that I dot I, unit vector, what we have to say, that I cap dot I cap, that is equals to magnitude of I into magnitude of I into cos 0. इसका magnitude कितना हुआ? 1. इसका magnitude 1 और cos 0 1, and that is equals to I. So we have to write that what we have, I cap dot I cap is equals to j cap dot j cap is equals to k cap dot k cap, and that is equals to 1. I dot I, j dot j, k dot k is equals to 1. This is the property of a unit vector. Sometimes multiple choice question may be asked on that. Scalar product obeys which what? Commutative law. It obeys distributive law. If two vectors are parallel to each other, scalar product of two vector is magnitude of two vector. Perpendicular, it should be 0. Anti-parallel, negative of magnitude of two vector. And unit vector, I cap, I dot I, j dot j, k dot k is equals to 1. And now what will happen for anti-parallel vector, perpendicular vector, I dot j is equals to j dot k is equals to k dot I, and that is equals to what we have, 0, because what? Cos 90 is 0. This angle is what we have, I आणि j मधला angle किती आहे? 90 degree, आणि cos 90 हा किती असतो? 0. म्हणून I dot j, j dot k, k dot I is equals to what? 0. This is the property for a scalar product unit vector. And the last one, we have to consider one more important property, that is A bar dot B bar is equals to what? What we have to say, that AX BX plus AY BY plus AZ BZ. Scalar product of two vectors can be expressed in terms of its Cartesian coordinate, because A bar is equals to what? AX into I cap plus AY into J cap plus AZ into K cap, and B bar is equals to what? BX into I cap plus BZ into K cap plus BY into J cap plus BZ into K cap. This is what we have to say, that the dot product of two vector, that is equals to product of Cartesian component of the two vector, that is A bar dot B bar is equals to AX BX plus AY BY plus AZ BZ. These are the some properties of the scalar product. We have to remember the definition. A bar dot B bar is equals to AB cos theta. A bar dot B bar is equals to AB cos theta. Now this is the first revision about the dot product. Now we have to discuss about the cross product. Write down these all things are very important. What do you mean by scalar product and vector product? Now cross product. It is also called as a vector product. Cross product or vector product, what we have to consider here. First of all, we have to consider a cross product. In the cross product, we have to write that first of all, A bar cross B bar is equals to AB sine of theta into n cap. Definition. क्रॉस प्रोडक्ट और वेक्टर प्रोडक्ट कशाला म्हणायचं बघा. क्रॉस प्रोडक्ट or it is also called as a vector product. Dot product is also called as a scalar product. Now in this cross product we have to say that A bar cross B bar is equals to AB sine of theta. How will you define? A cross product of two vector can be defined as the product of magnitude of two vector and sine of the smaller angle between them, and whose direction is what we have to say that perpendicular to the plane containing two vectors. This is what we have to say that first vector is say A bar, second vector is say B bar, and here a third vector, what we have to say that C bar is equals to what? That is A bar cross B bar, and here if the body rotates from, what we have to say that its direction is given by a right hand rule, and here C bar is equals to minus of A bar cross B bar, minus of what we have to say that A bar cross B bar. This is what we have to say that change in direction means we have a product of cross product of magnitude of two vector. This is magnitude of two vector can be defined as product of magnitude of two vector and sine of the smaller angle between them, and whose direction is given by plane containing two vector, and whose direction is what we have a perpendicular to the plane containing two vector. This is the plane we have, and third vector is what we have a perpendicular, and whose direction is given by a right hand thumb rule to a right hand rule. That is what we have to say that when vector what we have A is rotate to the B, at that time direction is upward, and if B is a rotate to the A, at that time what we have to say that direction is downward. So we have to say that a vector product of magnitude of two vector can be defined as a product of magnitude of two vector and sine of the smaller angle between them, and whose direction is given by a plane containing two vector, and whose direction is a perpendicular to the plane containing two vector, which is given by right hand rule. This is the definition what we have to say that scalar product. Then vector product. First properties. Property number one, it do not obey commutative law. it do not obey commutative law. That is, A bar cross B bar is not equal to B bar cross A bar, because here direction is changed. So it do not obeys the commutative law. Scalar product obeys the commutative law, but vector product do not obeys the commutative law. Secondly, we have it obeys the distributive law. That is, A bar cross B bar plus C bar is equals to A bar cross B bar plus A bar cross C bar. Distributive law. Obey. It obeys distributive law of vector multiplication. It obeys distributive law of vector multiplication. This is the very important property we have to discuss here. Third property we have third property we have to say that vector product of angle between two vectors, if theta is equals to 0, therefore A bar cross B bar is equals to AB sine of 0, and it gets 0. Means we have, if two vectors are parallel to each other, its scalar product, vector product is 0. And if theta is equals to 90, A bar cross B bar sine 90 is 1, that is AB sine of 90, and that is equals to AB. If two vectors are perpendicular to each other, its vector product is the product of magnitude of two vectors. And if they are antiparallel to each other, theta is equals to 180 degree. So A bar cross B bar is equals to AB sine of 180, and it gets 0. Fourth property, vector product of unit vector that is I cross I is equals to, what we have to say that magnitude of I cross I, magnitude of I is 1, another magnitude is 1, and sine 0 is what? 0. So we have to say that I cross I, J cross J, K cross K is equals to 0. Dot product मध्ये हे 1 असतं, vector product मध्ये हे 0 असतं. And another is what we have cyclic vector, that is we have to say that I, J and K. Cycle is moving like that, I to J, J to K, and K to I. So we have to say that I cross J, that is K, J cross K, that is I, and K cross I, it should be what we have to say that K cross I, it is J. And if the cycle is reverse, the sign is negative. Means what we have? J cross I minus K, K cross J minus I, like that. J cross I minus K, K cross J minus I cross K minus J. This is, the cycle may be negative. We have to consider for the unit vector. These are the four properties for a vector product, or it is also called as a cross product. And one more property, property number 5, that is vector product can be expressed in the form of a determinant. That is, we have to say that how it can be defined. That is, A bar cross B bar is equals to, what we have to say that I cap, J cap, K cap, AX, AY, AZ, BX, BY, BZ. And this is what we have to say that a property number, say 6, vector product expressed form of determinant. How determinant can be solved? We have, first of all, we have to say that I cap in the bracket. What we have to say that this can be multiplied like that. A.Y.B.Z minus A.Z.B.Y. Second is we have to say that minus sign. J cap in the bracket. J multiply this one. That is AX BZ minus AZBX. And third one is plus. That is K into bracket. This can be multiplied only this one. That is AX BY minus AY dx. This is the vector product can be expressed in the form of determinant, and determinant can be solved in this way. That is called as a vector product can be expressed in the form of determinant. This is the first article. We have to say that dot and cross product revision. We have to know dot product means A bar dot B bar is equals to AB cos of theta. Cross product means what? A cross B is equals to AB sin of theta. And we have some properties for dot product and cross product. Comparatively, we have to study. First property is what? Scalar product obeys what? Scalar product obeys a commutative law of vector multiplication. Vector product do not obey a commutative law of vector multiplication. Secondly, scalar product obeys distributive law. Vector product is also obeys distributive law. In the scalar product, if the two vectors are parallel to each other, then its scalar product is product of its magnitude. In the vector product, it should be 0. In the scalar, if two vectors are perpendicular to each other, at that time, angle between two vectors is say 90 degree, cos 90 is 0. So we have a scalar product is 0, but vector product is a product of magnitude of two vector. And lastly, third one, if they are antiparallel to each other, at that time what will happen? That is a scalar product having a negative sign of the product of magnitude of two vector, and vector product it should be 0. For the unit vector, that is I dot I is equals to J dot J is equals to K dot K is equals to 1 in the scalar product. In the vector product, I cross I, J cross J, K cross K, I cross I, J cross J, and K cross K is equals to what? 0. This is one more important property. I cross I, J cross J, K cross K, and that is equals to 0. In the dot product, it should be 1. In the scalar product, I dot J, it should be 0. But in the vector product, that is cyclic vector, I dot J, that is K, J dot K, that is I. Then K dot I, it should be J. This is called as cyclic vector property for the scalar product and vector product. And scalar product, it can be expressed in the form of Cartesian component, that is A bar dot B bar is equal to AX BX plus AY BY plus AZ BZ. Similarly, vector product can be expressed in the form of determinant. So we have to say that A bar plus B bar is equals to determinant of I, J, K, and what are the component of A? That is vector can be expressed in the three component AX, AY and AZ. B can be expressed on also three component BX, BY, BZ, and this can be solved this way. This is very important article for the scalar product and dot product. I hope we have to understand everything on this article, write down all the things, and after that we have to discuss very important article. That is, first of all, we have to discuss about the scalar product, vector product, and now scalar triple product and vector triple product can be discussed in the next lecture. Thank you.